I want to welcome David Tucker. His course is Amazing Discoveries in the Cosmos. It will start on May 4th. We welcome back David's expertise in studying the cosmos as he shares his love of astronomy with us. His National Science Foundation's Professional Award for Teaching Excellence says it all. His students love him and will welcome him back heartily. Welcome, David.
Thank you, Mishu. It's been about 5 years since I did an astronomy class, and a class on black holes. And so some major discoveries have occurred since then. Major progress in understanding the cosmos. And that's what I want to focus on, to get into some of the details of just what's happening out there in space. So I'm a ambassador to, there's a observatory over in Central Washington at Richland called LIGO. This is a gravity wave observatory, and I've been able to spend time with the actual PhD Nobel Prize winning astronomers there at this facility. And it's interesting that this LIGO, if you ever get a chance to do a field trip, go over there. It's just a fun field trip to go through, and you'll learn how they use gravity waves to identify black holes. And anyway, here are some of the recent discoveries. There are two ways to look at the cosmos to collect data. One way is using an optical telescope, like some people would be familiar with, the kind you're familiar with buying at the store and looking at the stars at night. And the other way is analyzing gravity waves that come from these monster black holes in outer space. So there are wonderful discoveries on both of them. I'll talk just a couple of minutes about optical ones. Everybody saw the picture in the newspaper and a whole bunch of other places showing the first picture of a black hole. And that was an awesome discovery. Just billions of miles away, they were able to, using radio wave optics, big dishes, big satellite dishes around the world, 5 or 6 or 7 of them, to create a virtual telescope that could measure the black hole in the constellation Virgo. It's not even, it's way outside of our Milky Way galaxy. And they picked this one in Virgo because it is like 10 billion, the mass of it is like 10 billion, the mass of our sun. And so just figuring out how they could take a picture of it, get the data back to Earth, and put it in a form that you and I could see was amazing. And another person that's made a wonderful discovery is a lady, Dr. Andrea Guest. She received the Nobel Prize last year. She is the director of the UCLA Keck astronomical team. And her work, she's been working for 30 years monitoring stars, dust, neutron stars, all kinds of things that are rotating around our black hole in the center of our galaxy. And so in 30 years, she has collected information that shows how these things rotate around the black hole, and it gives us an idea what's going on at the event horizon right outside of the black hole. And the last one I'll say here is in March of next year, the James Webb Space Telescope will be launched. And so that's one that's won't be here on Earth. We'll shoot it up as a satellite. And so it will be out there to address a number of different kinds of questions of what's going on in the universe. And so that's one way. Those are optical ways to measure things out in space. And I'll go back to just a few minutes to the gravity wave one. LIGO, they are now discovering 2 or 3 or 4 black holes that are revolving around each other. And so that's an entirely different thing. We wonder how black holes fit with our sun and other stars. And that's what this gravity wave observatory is doing. There'll be plenty for us to learn in those, and I'll just take about 3 or 4 of the big discoveries, things that I think are most important for people. And that's what we're going to do in that class. So thank you much.